A common unit used by chemists is known as the mole unit. Although sometimes it's abbreviated MOL, which I know it's not much of an abbreviation, we're just lopping off the E, but that's kind of what they do. But the mole unit is just a counting unit, just like the unit dozen. When you have a dozen of anything, you've got 12 of those things. So a dozen equals 12. So if you've got 43 eggs, and 1 dozen is equal to 12, then you've got 3.6 dozen eggs. Again, the mole unit's a counting unit. Just like a dozen, it's just a lot bigger. If you have a mole of something, you have 6.02 times 10 to the 23, whatever those things are. And sometimes this unit, or this number, is often referred to as Avogadro's number. So you can see it's a very, very big number. So it wouldn't be very useful in terms of eggs. But when you're dealing with atoms, which are very small things, it is a handy unit. So for example, you got 8.3 times 10 to the 24 atoms, which seems like a lot, but you probably have at least that many in your hand, or maybe in this pad of paper. If you've got a mole of atoms, or a mole of anything, you got 6.02 times 10 to the 23 of those things. So we have 13.8 moles worth of atoms. So again, converting between individual atoms to converting it to the mole scale isn't really any different from, dealing with the dozen unit. So don't let the size of the number and the fact that it's a new unit throw you off. And also notice that we're using dimensional analysis here to convert between one unit to another, which we talked about in a previous video. A related unit is what's known as molar mass. And this is the mass of 1 mole of a substance in units of grams. So the unit of molar mass is so many grams per mole. And the way it works out, if you have 1 atomic mass unit, that's equal to 1 gram per mole. So the atomic weights that you see on the bottom of the periodic table, you were probably initially taught them in units of AMUs. Typically from this point on, you're going to think about them almost exclusively in units of gram per mole, in molar mass units. The handy thing about the molar mass unit is that it allows us to convert between the gram unit and the mole unit. So whenever you want to convert between grams or moles, you're going to use molar mass. So we use molar mass as a conversion factor. So for example, if you got 5 moles of carbon, if you look on the periodic table, it's got an atomic weight that's 12.01 with 4 sig figs. Again, if we think about that in terms of grams per mole, it's that many grams of carbon per 1 mole of carbon. So using dimensional analysis and using the molar mass as a conversion factor, we find that in 5 moles of carbon, we have 60.1 grams. And one other example, going the other way. Let's say you're starting with 15 grams of CO2, and you want to convert that to moles. Okay, if you add up the atomic weights of that 1 carbon and those 2 oxygens, that gives you a total of 44.01 grams per mole. Now we want the gram unit to cancel, so we've got to flip the atomic weight around, and it's 44.01 grams of CO2 per 1 mole. So that gives you 0.341 moles of carbon.